Last time we got a very basic, rough example of using the Wiggle API to initialize an OpenGL context. In this video, I'm doing a second pass over that code to clean it up and get it ready for putting it into the main code base. So right now it's sort of a rough example. It has a lot of things hacked around the edges. The error handling isn't segregated out. The different parts of initialization, so initializing the main OpenGL system and then initializing an OpenGL renderable window, they're not separated out in any way, and nothing's really organized either. I just sort of threw in all the definitions I needed. And so I want to make sure that it's going to be possible to split this up into the relevant sort of independent parts, and once the example's in that state, it'll be easier to transfer the code without too much modification into the code base properly. The first thing I like to do, even though I have some amount of idea of what I want to work on, is to review the code that I'm about to clean up. So this is not a very in-depth process, but I am just sort of skimming through. I'm making sure I notice all of the to-dos I left inside the code, because while I have a notebook, I also have to-dos in the code, so I'm sort of getting it all in my head. What was I thinking about that I wrote down? What was tied to specific points in the code? I'm also reminding myself of what the current structure of the code is, because once I remember where I'm at so far, I won't have weird distortions in my head like, oh, I thought I already pulled this out into a function, but actually I was just thinking about pulling it out into a function. That kind of thing can make stuff confusing. So I just like to skim the code, get it back in my head the way it actually is so far, and from there come up with the plan of what I'm going to try to do in one session. And in some cases, I can even come up with a plan of how to do things in a certain order to make them as easy as possible to get right. So with this, I am ready to go and start actually making the cleanup code changes. So the first change I'm going to make is that there's a lot of function loading that I'm doing here, and I want to organize that in a way that will reduce the amount of code, because right now there's a type def where I have to type in the name and the signature. There's then a declaration of the function pointer variable, and that uses the name once for the type, the name again for the variable, and then I have the part where I load the function in, and that uses the variable name 3 more times, once to name the variable we're trying to set, once to cast to the function's type, and once again as the string parameter that tells getProcAddress what function we're trying to load. And then after that, I also check if it's null and report an error, so I'm just getting lots and lots of repetitions of each thing I want to load. So the way I'm going to handle this is through probably the only thing you might call metaprogramming in C, which is an X list, which lets you make a list of things that is sort of like a table that you want to instantiate into code in different ways at different places. In this case, I'm doing X lists in separate headers. This is an easy way to get the X list right without having to use backslashes, which you need for multi-line macros, which is kind of annoying. I'm going to end up later on in the series undoing this decision, because there is something I don't like about this, which is I don't like examples being spread out into lots and lots of files. A good example fits in one file. But for now, it's not an example that I'm trying to give to other people. It's more so my space for organizing my process here. So I'm going to sort of break the rule of a good example for now in order to get me halfway between where I am and where I want to be. And later I will make the example a single file again, and I will copy out the XList headers. But for now, this is what we're doing. So let me give a quick idea of how an XList header works in case it's a new idea. The idea is you have one header that doesn't really look like C code, but it's essentially a file that is just instantiating a usage of a macro over and over again. And classically, the macro that you use for this is the macro X, although it could be anything. So I'm doing X and then an open parenthesis and then a list of parameters to that macro and then a close parenthesis and then another one, however many I have. So to make functions, what I do is I make an X, open parenthesis, the name of the function without any of the decorations. So like if I'm going to decorate it once to make a type version of the function and another to make a variable version of the function, I don't include those decorations. I just include the raw name and then a comma and then the return type. And that's return type without parentheses or anything. Just if it's a pointer, you put the star in there, whatever the expression is that creates the type expression for the return type of the function you're trying to load, that goes into this parameter, and then comma, and then there's a parameter list. And the tricky thing about a parameter list is I don't want to have like a variadic macro become involved, because that makes things a lot trickier and less standard between compilers. But what you can do is you can use an extra parenthesis to open and close the parameter list. So it goes comma after the return type, and then an open parenthesis, the list of parameters, and then the close parenthesis for the parameter list, and another close parenthesis for the macro. And so this creates 3 parameters to the macro, where the third parameter is an entire parenthesized expression. And that becomes the system I use to stamp out these functions at different places. I can use it to generate type defs once. I can use it to generate the function pointers once. I can use it to generate all of the loading of the procedures eventually and all of the checking that the procedure is loaded successfully. So that'll work. And then the only other thing I have to do is separate this out into different types of functions. So if I'm going to load some functions from one module and some functions from a different module, or if I'm going to load them at different times or through different get proc address flavored functions, then I need them in separate X lists so that I can not try to do them all at once, but do them piece by piece. So I have one X list for all of my wiggle functions, one X list for all of my extension wiggle functions, and then one X list for all of my plain OpenGL functions. So there's one pretty annoying issue that I mentioned a minute ago, actually, which is that the getProc address function, it has some issues when you call it. So generally, when you're loading a function with getProc address, you have a function with some actual signature on it. It's got some parameters, it has a return. And each one is going to be a little different because you don't end up usually having all of your functions have the same signature. That's just not the expected case. The expected thing is that there are lots of different kinds of functions with different types. And yet when you do getProc address, you want it to look like all your functions have the same type, because they do. They all are just pointers underneath the hood, and they all have some string name associated to them that lets you load them out of a DLL. So what you would want is you can get proc address for any function type and it just works. But the C++ casting rules around pointers and function pointers don't quite allow that, so you end up having to cast the return for every call to get proc address to make it match the function pointer type that you're trying to assign. So my idea was to make a macro that flips this relationship around. Instead of casting on the return of getProc address every time, what if I casted the L value? What if I casted the variable I'm trying to set to make it look like it was just a plain no parameters, no return function, which is the type of function that the getProc address is going to think it's returning to us. That way the type checker will can go, okay, first I have this function pointer, but I'm going to cast it to some generic untyped function pointer essentially. And then I'm going to assign that thing by getting the value from getProc address, and whatever that returns, I'm going to assign it into this. And then it'll look and see that they have the same type. So the idea is, instead of having a different cast on the getProc address every time, I have the same cast on the L value, or the left-hand side of the assignment, every time. And this gets rid of one layer of complexity where otherwise I would have to, even if I made a macro for this, I would still have to pass in the function pointer and its type to generate the cast, or I'd have to make some kind of weird rule about how I'm going to use a single name, and then I'm going to decorate that name in two different ways. So I could never load a function where the name of the function didn't match the type of the function pointer exactly using this macro, which just seems silly. So the idea I came up with was the one I explained, cast on the left-hand side, to get rid of the typefulness of the left-hand side, and that can be done in the same way no matter what type we actually are using for the function pointer. And so I'm implementing that macro. I have to do a couple of flavors of it because getProc address is not the only way I'm loading procedures in this code. And then I'm using that to simplify a lot of that procedure loading code. Next, I'm taking this example and I'm splitting it up into two separate functions. One of those functions is for initializing the OpenGL system itself. That includes all the stuff about the bootstrapping that we talked about last time, and in theory it could also involve things like setting up a shared context if we were going to have multiple contexts for multiple windows, for instance, although we're not doing any of that stuff yet. But this is where we set up all of the global stuff that you need just once for the entire process, no matter how many windows you have or how many styles of rendering you're going to have or whatever else. There's just one of these global initialization paths. And then a separate path will be the one for creating a window. And for now, we're not actually being super careful or robust about being multi-window, although I think we want to get there soon. So I'm not going to go through and make sure it actually works to create multi-window setups, but I am splitting things out that way so that I don't have any crisscrossing dependencies. There aren't any variables or aspects of the error handling that are tying these two parts together. That way we know that they will be sort of evolving separately, and when the time comes to have multiple windows, we won't have to first refactor things so that it's even possible to create a window in a separate path from initializing everything else. The last big thing I want to fix up in this pass is the way I'm handling errors in the functions that I just split out. So first of all, let's take a look at what I'm doing right now. I have these lines that'll be like error equals some string if something failed. So if I failed to load a function, if I failed to create the window, whatever, I say what happened in the error string and then I go to done, where done is a label at the very end of the function that skips over everything else. Now, I don't really like using the goto that way, not because I have a problem with goto in particular, but because I have a problem with skipping over code in that way. I like it when I can deduce from a line of code whether or not it gets executed by looking at what scopes it's in. So if you use things like goto, early returns, breaks, and continues, these tend to create situations where they skip over some amount of code without actually indicating that they're skipping over code by putting that code in a block. This is an idea that's a little hard maybe to understand by explaining it and just listening, so maybe this picture will help. Go-tos and early breaks and early returns and things like that are ways of jumping over code like in this diagram. But what I tend to find is that that will become confusing at some point. That code that gets skipped over is not code that you know is getting skipped over. If you accidentally forget and you think you can log something or you think you can guarantee a particular behavior by throwing in a little extra check or something, and you throw it into this code, well, if you forgot that that code is sometimes skipped over, you have a problem. This actually comes up in another case here, which is the second big thing I need to fix, which is that I have some code that creates a resource. In this case, it's get DC, and I need to release the DC before I leave the function. But if I have an error and that error goes to the done label and totally skips over the release DC that I thought was going to happen, then this is exactly the kind of issue I'm talking about. So I want to try to write everything using no skipping forward except via ifs. Ifs actually give you a way to skip forward, and the cool thing about them is that they actually document when some piece of code won't happen. You can look at a line and say, what scopes is this line in? If any of those are ifs, that tells you when that line will get skipped. So if at all possible, I like to avoid early returns, early go-tos, early breaks, and skipping over blocks of code. And for long functions like these that are doing lots of tedious stuff and error handling, I think it's even more important to follow those rules. If I was trying to implement a fast algorithm, that's when I might break the rule. But in this case, I'm going to, instead of using go to done everywhere, I'm going to just begin every block of code that does some important step of the setup with an if, and that if is going to say if I don't already have an error. So the top level of my code, instead of having those branches like I was showing in this diagram, they're going to instead just be a series of things that I want to do, where each thing will say, if we don't already have an error, then do this, and then it'll go on to check the next block. And so it might be the case that the very first thing gets an error, and then we do 5 more blocks that are all just, oh, there was an error, skip to the next block, oh, there was an error, skip to the next block. The cool thing is a smart compiler that does any amount of optimization at all is going to look at that and see that as soon as there's one error, it can skip to the end. So it will actually generate perfectly reasonable code. And I think that this is actually the most readable thing, because now it is completely documented by the code itself when a line of code isn't going to be executed. There's no hidden skipping happening anywhere. So this is the style I'm going to go with. I don't know if that'll be controversial. Some people might like it and other people might dislike it. A lot of people like early returns. A lot of people don't like go-tos. So who knows what everyone's going to think about this. But I strongly advocate for considering this sort of blocking of code and using ifs to sort of create a chain of operations that can all be skipped in one go if the first one fails without really costing anything at the low level. And I think it makes the code more readable. So this stuff is looking good. Next time I'm going to start abstracting it. See you then.